Let's graph the following conic section. For a hyperbola, we'll list the foci and we'll also name the asymptotes. We have 9x squared minus 4y squared equals 36. First, we need to determine what type of conic section it is. We'll notice that the x squared and y squared are both on the same side of the equation, and the x squared has a positive coefficient and the y squared has a negative coefficient, so this indicates that it's a hyperbola. Now we want to get the hyperbola in standard form, so we need a 1 on the right-hand side, and we'll divide each term on both sides by 36. Now we have x squared over 4 minus y squared over 9 is equal to 1. This is in standard form because it's of the form x squared over a squared minus y squared over b squared is equal to 1. We can see that the a squared is equal to 4, so that means that a is equal to 2, and also b squared equals 9, so that b is equal to 3. We can also see that the center is located at 0, 0, because we don't have x plus or minus some quantity squared or y plus or minus some quantity squared. So let's start first with this information. Let's put the center, and since a is equal to 2, we need to go 2 units to the right and 2 units to the left of the center along the x-axis, because the x-axis is the transverse axis. So 2 units to the right, that's our first vertex, and 2 units to the left, that's our second vertex. Now, in order to graph this hyperbola, from the center, we'll also go 3 units up and 3 units down along the y-axis, because b is equal to 3. And then we'll draw a rectangular box containing those 4 points that I just graphed, and we'll draw diagonals through the corners of this rectangular box. These diagonals are the asymptotes that will help us draw the hyperbola. Now we need a couple more pieces of information. We actually have enough to sketch the branches of the hyperbola right now, so I'm going to sketch those in red. From the vertex 2, 0, I'll draw the branches out going toward the asymptotes, and also from the other vertex, negative 2, 0, I'll draw the branches. So we're asked for a little bit more information. Although we don't need the foci to graph the equation, we can still come up with the points where the foci are located. So in a hyperbola, we know that we have the relationship that c squared is equal to a squared plus b squared. So we have c squared is equal to a squared, which is 4, plus b squared, which is 9. So c squared is equal to 13. Therefore, c is equal to plus or minus the square root of 13. So each focus is also located on this transverse axis. So from the center, we go the square root of 13 units to the right, which is about the coordinates of the first focus would be the square root of 13, comma 0. That's one focus. And the other one would be negative square root of 13, comma 0. Now we're asked for one more piece of information. We want the equations for the asymptotes. So we have asymptotes that are of the form y equals plus or minus b over a times x. We always use these equations for asymptotes, y equals plus or minus b over ax, when our x squared term has a positive coefficient. In other words, when the branches of the hyperbola cross through the x-axis, this is the equation that we use. So in our case, we have y is equal to plus or minus b, which is 3, over a, which is 2x. So I'm going to highlight the information that we have. Y is equal to plus or minus 3 over 2x are the equations for the two asymptotes, these two diagonals that I drew through here. The location of the foci are right here, plus or minus the square root of 13 and 0. The vertex is located at 2, 0, and the other vertex is at negative 2, 0. And here is the graph of our hyperbola.